Hey everyone, here's a latest hack job I've done. This one is a Galaxy 959, which I got from the States, I don't know, a year or so ago, and thought I would finally get around to working on this one. I've added a few things to it. Probably the first thing you'll notice is put a color LCD in here, and I replaced the LED here as well. This is a 959, not a 959B. I put in an ESP32 to control it and a 5351 as the clock source, and the 5351 has a TCXO fitted to it, so it's accurate to within a couple of hertz. I also so I'll quickly show you the LCD. I don't know why it's showing blue in the background. It's actually it's black, but you know, I don't know. It's my camera. So the LCD fits in here really well, and I think it was about $5 or $6 for the LCD module. So that was pretty good. And it's controlled by an SPI bus from the ESP32, and this is controlled by an I2C. I'll show you that when I open it up. So basic operation I did with this is that the channel dial is normally a 10kc channel change, and it jumps onto all of the subs as well. I call them subs. What are they? Alpha channels. And the display here shows what mode you're in as well. So USB, LSB, etc. When you press the channel dial, it'll put a small line underneath this digit, and what that means is that it's now in 1kc steps. And when you press the channel dial again, it gives a slightly different underscore there, and that's a 5kc step, but it steps on the zeros and the fives only. So you'll see it jumps from zeros to fives. I figure because that's probably the most that people are going to want to, most people are going to want to use that step as much as anything else, especially when you get outside the regular 40. And then when you press the button again, it just goes back to the regular 10kc step. So press it once, 1kc, press it again, zeros and fives, and press it again, and it's 10kc. So I think that's probably the most, I find that the most sort of intuitive and easy way to use a dial that's set up to sort of act like a VFO as well. So it works quite nicely. What else? Let's see. Yeah, if you can see it's kind of like a yellow at the moment. If you hold this down, it changes color. So you can have green. Don't know how well this shows up on the camera. Red, sort of a mauve color. Orange, blue, sort of a light green. That's white. That's a bit darker, bit darker, bit darker. That doesn't show up very well at all. Blue. That's sort of like a cyan. That's a purple. Doesn't look good. And yellow. The other thing I did, the clarifier, I replaced the clarifier with a rotary encoder as well. So that clarifier, if I can show you, clarifier just jumps in 10kc, 10 hertz steps. I don't know how well this is going to show. And so what it does, instead of changing the frequency here, like I've done on other radios, I think it's more important and more, I don't know, it's just an easier way to say, you know, you're 20, for this example, 27085 and you're 160 hertz high, or, you know, 27085 and you're 140 hertz low. Better than trying to actually change the frequency and work out where you are from that channel, because you know on CB it's really about the channels. So I think it's just much more intuitive and much easier to say whether you're sort of plus or minus from a particular frequency. That's probably what everyone wants to know, how far off frequency they are. So they go up to 990 and then back again. It's green because that shows that it's in receive only. If you press the clarifier, it goes to TXRX, and now it's in red, and so that means that it's unlocked clarifier basically. So now it's changing the transmit and the receive together. So press it again, RX, and it's green. So now you receive only. So basically that means that you're receiving 220 hertz high in this case, but your transmit's still bang on 27085. So you're only moving your receiver here, which is great because, you know, if someone's off frequency, you don't really want to drag yourself off frequency to talk to them. And then, you know, the next guy comes along and he drags himself off, and pretty soon you've got everyone off frequency. So I think it's good to have a locked clarifier when you can, but if you want to, press that and TXRX goes red or orange, and you know that you've dragged your transmitter and your receiver off frequency here. If you press and hold it, it goes back to 0. And when it's on 0, it doesn't show you 0. I like to have an uncluttered display. So see, minus 10, plus 10, 20. So you can roll yourself off here. RX only. Press and hold. Back to 0. What else have I done on this thing? It's got an echo board fitted to it as well, so that's on the mic gain. So the mic gain is the echo, and everything else is kind of standard except the dimmer doesn't work anymore. RF power control works, everything works. And I don't know, this came with this Cobra microphone, and I don't know what it's from. It's a power mic. Maybe someone can let me know what that comes from, but it normally has a battery in it, but actually what I did, it was really easy just to put one small resistor inside the radio and feed the power to the power mic up the line. So this doesn't have a battery in it, it's empty, and when you press it you can see it's still got power because the power's fed up the line from the radio now. It doesn't stop the radio from working with a regular microphone, but yeah, I don't know what this is from or if it's any good. It seems to sound all right. Yeah, I think probably that's about it. Echo, clarifier, what else? Yeah, I think that's probably about it. Frequency coverage goes to 27995. Well, 27999, I guess, and 26 meg up. You know, so if you're feeling ambitious, you can scroll through the whole band 1 kc at a time. It's probably better to go 5 kc. Now down here we've got the New Zealand channels on the zeros, and you know, a lot of the international stuff is on the zeros as well. So yeah, it's just a continuous roll through, and then roll around again. Just keeps going and going. Yeah, this is a pretty nice condition, this radio. It came, you know, the meter's not faded at all. Like I know a lot of them can get faded. Yeah, that's about it for the outside. I'll show you what I did on the inside. Okay, so there's the inside. You can see that I've put the ESP32 over here, mounted on some standoffs, some brass standoffs here. And then what I did with the ESP32, I just mounted these plugs on the side on both sides, and then that lets me easily just tap in any of the wires that I want to run off to anywhere in the circuit. That was a really easy way to do it. And then, you know, you can pull these pins out of the plugs and just move them around and kind of juggle things around like that. So that's, you know, like a super simple way to mount one of these ESP32s or any Arduino in the radio. So you know, I'll probably do that in future instead of trying to individually wire them all up to different plugs and stuff. Just, you know, I just put like a 6 and an 8 pin plug on each side, and then you know, you can just basically use whichever pins you want, and you can change things on the fly and that kind of stuff. There's a couple of pins here. Unfortunately, I had to use multiple connections on it, like this one, because this LCD, this LED driver is I2C, which I've covered in other videos before. But it's yeah, basically a LED block, which is a common cathode block, which mounts onto this little breakout board kind of thing, or this, yeah, I can't remember what the name of the IC is, but basically it converts this LED block into an I2C bus, so you can control it from I2C. And the 5351 is also I2C, and a lot of LCDs are also I2C, and OLEDs are I2C as well, but this one uses SPI because I wanted it to be fast. 5351 board I've got mounted in here, and this is the cable that runs back to the processor, which supplies the voltage, the supply voltage to the 5351, and then this is the clock and the data lines, the I2C lines that run into here as well. So super easy way to convert a radio is you know, like sticking an ESP32 or a nano or whatever, and sticking some plugs on it like that, and then, you know, you can just, you know, plug everything into it super easy. You don't need any other boards for it. This thing's just got some header plugs, the right angle header plugs here, which mount into the board, but I don't actually use them for anything except giving some way to mount this board in there. So I just used some pins that weren't used, some holes in the board that weren't really used for anything, I think, and then you can mount it in there. And then this has just got this right angle, it's got one of these plugs on it, one of these sockets on this board, but it's one of those right angle ones, so I can't really show it, but anyway, it just plugs, it solders on, it's a right angle one. So then you can plug onto here and take it off. Super easy way to do it as well, so I'm going to probably do that more in future as well. And then I've got two coaxial cables coming off the Si5351. One goes to this clock over here, and the other one comes back here and replaces this oscillator. So, you know, the VCO and the PLL are not used anymore. They're just taken out of circuit. And then the 5351, this is your channel. I call it the channel clock. That plugs in here or connects in here. And then this one here is the mode clock, which I call a mode clock. So basically all of these controls, all of these coils, and all of these coils are no longer in use. The crystals are gone as well. So that makes this thing super stable, rock steady, spot on frequency. What else have I done to this? These boards are built to have dual MOSFETs in them, so I changed the driver and the two outputs to 520 MOSFETs, so it's got basically three 520s in there, as per, I think it built up around the circuit of, I think it's a 98, Galaxy 98 or something had this here, so I had the circuit for that. And basically all these parts on the board, all the slots on the board and everything are kind of ready to go. Like this wasn't in here, and a few of the components were missing, but it was pretty easy to just replace the parts and switch this from a 1969 final, single 1969 final, into a dual MOSFET. That was pretty easy. And I think I changed this coil here, this choke, to work a bit better. I think that might need changing, but anyway, it works okay. I think it puts out about 15 or 18 watts average, so on sideband, so that's pretty good. Good enough, and you know, it's not running hot, and it's not overdriven or anything like that, so it'll put out 15 to 18 watts sort of comfortably all day now. So but the Echo board I managed to sort of shoehorn in here. It fits really nicely. Again, it's got some standoffs here, and yeah, that worked pretty well. What else did I do? Yeah, that's about it. Oh, the 5351 has got a TCXO on there. Don't know if you can see that, but I've covered that in some other videos. I'll see if I can put a link to that. and it makes it super accurate on frequency. I'll just quickly show you. So if I go to so 27000 and AM carrier AM. So 27000, yeah. So these things are super accurate to within, you know, 1 or 2 hertz, and they don't drift at all. So they're good from, you know, 5 seconds after you switch on. They're rock steady on a frequency. So let's see how accurate that is. And if I take that up to TXRX plus 10 hertz high. Yeah, so you can see it's sort of within 1 hertz of being on frequency. I forgot to show you the boot screen. So let me see if I can make this look good. I don't know why this color's so crap on this camera. All right. All right, there you go. That's the boot screen. There's an extra 3 watts of power right there. Because of that, I know, I checked it out. True story. All right, see you later.